Alright, so today we are talking about the equations of parallel and perpendicular lines. Some of this might be review from Algebra 1, but let's talk about it just in case you have forgotten. So the first thing that we want to remember is the slope of a line. So we can remember that the slope of the line basically tells us which direction the line points. So when we say the slope, we always give it as a fraction. It always is given in the form of rise over run. So the top of the fraction tells us whether we are going up or down and how far. And then the run tells us how far over we need to go. So the formula that we're going to use to find that is y2 minus y1 over x2 minus x1. So given 2 points, think of it like we are figuring out how far up and down we go and dividing it by how far side to side we go. How this relates back to what we're talking about today and before is with parallel and perpendicular lines. So we said if the slope of the line describes the direction that the line goes, and we know that parallel lines have to go in the same direction, then that means parallel lines will have to have the same slope. So if you look at the picture they gave us, line M and line L are parallel, and they both have a slope of 4. For perpendicular lines, they're not going to have the same slope because they need to cross, but they're going to have a specific type of slope in order to cross exactly at a right angle. So the pattern in the slopes for perpendicular lines is that they always multiply to -1. And so you may have seen this last year. The term that we use is opposite reciprocals. Again, if you think of the 4 over 1 as a fraction, you flip the fraction over and then put a negative sign. If there wasn't one, if it already was negative, it switches to positive. Doing this will make sure that they always multiply to -1. So let's look at an example. So they've given us some points, and they want to know whether the lines formed by these points are parallel, perpendicular, or neither. So we have 2 points, A and B, for the first line. So I'm going to just copy down the points again. So A is 1, 1, and B is -1, -5. If I want to know which direction this line points, I need to find the slope. So from A to B, I'm going to take my y2 minus my y1 and subtract x2 minus x1. So we're going to subtract the y's and then subtract the x's. So for my y's, that's going to be -5 minus 1. For my x's, it's going to be -1 minus 1. So I do that, -6 on top, -2 on bottom, and if I reduce that, it just equals to 3. Alright, so then we know point C is 3, 2, and point D is 6, 1. Again, they want to tell us to connect points C and D to make a line. So my slope is going to have to go from point C to point D. So if I make my fraction, I'm going to do 1 minus 2, again connecting the two y's. And then on the bottom, we'll do 6 minus 3, again connecting the two x's. and then simplify. So 1 minus 2 gives me negative 1. 6 minus 3 gives me 3. And so to compare, 3 times negative 1/3 is equal to negative 1. So they are perpendicular. Again, they weren't the same, so they can't be parallel. But if their slopes are negative reciprocal, or if they multiply to negative 1, they are perpendicular. So what we'll do is say AB is perpendicular to CD. Again, perpendicular sign is going to look like an upside down T because we're trying to draw some right angles. Alright, and so here's a couple extra examples. Calculate the slope between the points that are connected and see what we get. Okay, so for example 2, this time it's asking us to graph a line that contains the given point. It's got to be perpendicular to CD, and then we've got the coordinates for C and D. So since it specifically told us to graph, let's draw a picture. So we're going to need an X and Y. We know that A is at negative 3, 0. Put a little A there. I know that D is at 2, 0. And we know that C is at negative 2, negative 3. Alright, so the first thing we probably want to do is draw the line from C to D. We said it needs to be perpendicular. So that means I'm going to need the slope from C to D. C is negative 2 and negative 3. And point D is 2, 0. Alright, again, we're going to find our slope, so we're going to connect the y's, connect the x's, and it's rise over run, so 0 minus negative 3 over 2 minus negative 2. Again, be careful of the negatives because we should not get 0 on the bottom. So 0 minus negative 3 is 3. 2 minus negative 2 is 4. And if I want a perpendicular slope, I'm going to flip the fraction, put a negative. So, let's go back to our graph. The slope of the second line must be negative 4/3. So that means I'm going to start at point A. I'm going to go down 4 and over 3. So 1, 2, 3, 4. Over 1, 2, 3. Put my point here. And when I draw my line, it should be perpendicular. And there we go. So again, try example 4 on your own. Got one more to look at, which is basically going to be writing the equations based on the information that they give us. So we've got two formulas we're going to use. One of them we've probably seen a lot before, slope-intercept form. So that's our y equals mx plus b. M is the slope. B is where we cross the y-axis. The other formula is the point-slope form. So notice we still have m as the slope, only now instead of having a specific y-intercept, we have a random point on the line that it has to cross through, and so those are just going to get plugged in for x1 and y1. The other thing to remember is that anytime you see an equation where it's y equals a number, it's always going to create a horizontal line. That might be backwards from the way we think of it, but here's how it works. You know you have to hit y at -3 because it says. So I go to -3 on the y-axis. I don't see an x, so I have to draw it so that it never hits the x-axis, and I go this way. So the x equals a number will be vertical for the same reason that the y line worked. So if I want to graph x equals -2, notice here's -2 on the x-axis. If I don't want to hit the y-axis, I have to go straight up and down. Alright, so how are we going to use this? Well, what they're going to do is give us some information and ask for a formula. So we need a line that's perpendicular to -3x plus 2, and it has to hit the point 4, 0. They want the line in slope-intercept form, so that's again going to be our y equals mx plus b. So let's look at what we know. This line is in slope-intercept form. The slope is -3. I want my line to be perpendicular, so it's going to have the negative reciprocal slope, right? So let's make this into a fraction. We're going to reverse the fraction, and since this side had a negative sign, I'm going to leave this one as a positive. I also know it has to pass through 4, 0. So since I don't have the y-intercept given to me, I will use the point slope formula. So it's y minus y1 equals m times x minus x1. So when I plug it in, I'm going to take the coordinates from the point they gave me and the slope that I just figured out and plug it in. Again, the problem asked us to write it as a slope-intercept form. So I'm going to need to simplify this. So y minus 0, we know is equal to y. We know if there's a number in front of the parentheses, we're just going to distribute. So 1/3 times x gives me 1/3. And then 1/3 times 4 gives me 4/3. I now have it matching the mx plus b formula. So that's my answer. All right. That's the last example for today. Try number 5 on your own, and I will see you next time.